Hi friends, welcome to my channel. Let's have a look at problem 1926, nearest exit from entrance in maze. So in this video, we're going to share a solution based on breadth-first search. So here our main goal is to emphasize the treatment to avoid repetition in the traversal. So this problem requires to return the number of steps in the shortest path from the entrance to the nearest exit, or a -1 if no such path exists. So here are some examples. For example, in example 1, so the output is 1, so he can move. The person can move one step upwards. So in the second example, the output is 2, and the person can move to the right 2 steps. So notice that in this problem, the entrance is in the boundary, lies in the boundary. So the exit cannot be the same as the entrance position. So in example 3, so this is a very special case. So because the person lies in the boundary, or the entrance lies in the boundary, so there's no other boundaries, so the output is -1. So the constraints on this problem are mainly on the size of the maze. So the number of rows and number of columns are m and n respectively, and both of the two numbers are bounded in between 1 and 100. So in this problem, the dot means empty and plus means wall. So the entrance will always be an empty cell. So this finishes the main statement and assumptions in this problem. Now let's look at the method. So as we mentioned, the method is breadth-first search, and here the breadth-first search is single source. The source is actually the position tuple corresponding to the entrance position. So in this problem, actually the logic is relatively simple. So the stop condition is easy to recognize. That is, when we meet a boundary empty cell, notice that when the entrance lies in the boundary, so the exit cannot be the entrance. So here in this video, actually we want to emphasize the treatment to avoid repetition during the traversal. Typically, if we use breadth-first search or depth-first search, we will use a set data structure as a helper to avoid repetition. And here in this specific problem, what we are going to do is the following. So once we visited an empty cell starting from entrance position, we're going to reset the maze value corresponding to that position to be plus, that is a wall, to mark it's visited. So with that said, I guess we are ready to look at the shortcode. So first, I'm going to make some preparations, like track the information for the number of rows, number of columns, and then we're going to write a helper function to do the breadth-first search. So in between, we're going to track the distance information, and finally we call the helper function and do the return. So first, let me get m and n. So m is maze of length, and second is maze 0, right? So that's the number of rows and number of columns. So next is the breadth-first search helper function. So in this function, we're going to accept a position as a tuple as a argument. So this is going to be our entrance tuple, so in the function call. So we're going to return a distance. So for this purpose, we're going to use a queue as a container, so collections deck. I'm going to use this container as a helper for mimicking the queue behavior. So this is, and also we need to return at a distance. So what I get is this. So let me make it a tuple. So let's see, this is right, and this is the empty bracket. This is a bracket. It's also right. So what we return actually, what we store actually nothing but RC and distance. So for the entrance, we set the distance is 0. So with that said, let's do the iteration. So it's a while loop. So while queue. So notice that we didn't initialize a set here. So as we mentioned in the item 2 here. So what we are going to do is that we first get the position and distance we're looking at, top left. The first thing is that I want to mark this RC to be a wall, because this is visited. And then we are going to check if this position RC corresponds to a valid exit. So if, let's see, I will use R in the 0 n minus 1 or C in 0 n minus 1. So this is the conditions for the row and or column index for position RC being in the boundary, right? So this is one condition, and also we need to check this position is not the entrance. So we're going to check and not. So this R equals entrance 0 and C equals entrance 1, right? So if this is the case, we find an exit which is valid, so we're going to return the distance. Otherwise, we're going to look at the 4 directions. Let me push this a little bit to make it easy to observe. And then we're going to check the 4 neighbors. So for xy in r minus 1 c, r plus 1 c, r c plus 1, r c minus 1. We are going to check if this position is inbound at not visited yet. So if 0 less or equal than x less than m, and 0 less or equal than y less than n, and so this position is not visited. In other words, it means this one not equals positive. So this actually serves two purposes. First, it checks because if this position does not equal to positive, it means that it's either not visited or it's an empty cell, right? This empty cell is what we are going to enqueue. So we're going to enqueue this position xy with the distance incremented by 1. And here, one thing that is important is we're going to change this xy to be a wall after we enqueue it. So this is going to be important to avoid repetition. So once we've done this one, if nothing is returned during the while loop, we're going to return -1. So that's the second step. So the third step actually is the return. So this is routine. We're going to return breadth first search. We're going to pass a tuple corresponding to a position to the function. So that is the entrance here. And then that's it for this problem. So before we analyze one more point, let's do a special case check. Oh yeah, it passes a special case. Now let's look at the generic case. So it passes all the generic cases. So here is one thing. So in this one, because we have changed this here, we can comment out this one. So if we check, it passes all the cases. So but logically, I would like to add this here. The reason is I want to change this position entrance also to be a wall. So that's just a personal preference. Yeah. So with that said, I guess that's about it for this problem. So you're welcome to check out other videos in my playlist or channel. Thank you so much.